Good afternoon, everyone, and welcome to National Chemistry Week and our Science in Action program. My name is Christina. I'll be serving as your moderator today. And although you can see my face now, you'll mostly be hearing my voice in the background once we meet our educators. And in just a few moments, we are going to meet an educator from the Museum of Science and a guest educator today to lead us in experiments all about the science of slime. If you would like to follow along today and maybe make slime with us, you can see the ingredients that we'll be using for this experiment today, or you can take note of them and try to do this after the show or maybe later this week or later this weekend. If you are watching on social media, so Facebook or YouTube today, we are going to be putting these ingredients in our description as well down in the comments on social media. Now, if you would like to ask a question, share an observation, or answer any of the questions that our educators pose to you, and you're watching us on Zoom, you can do so by clicking on the Q&A button at the bottom of your screen. And don't forget to include your name and age if you would like a shout out. If you need captions today, you can get those by clicking on the closed caption button and then selecting show captions. If you happen to be watching on YouTube or Facebook today, unfortunately, we will not be able to see your comments or questions, but we're so happy to have you join us for the program, and we hope you enjoy the show. Now, with all that being said, I would like to invite our educators to turn on their cameras, introduce themselves, and get us started.
Hi, my name is Vaishnavi. I'm a third-year grad student in the Department of Chemistry at MIT, and today I will be showing you all how to make slime. I'll be happy to take any questions and answer them as best as I can. I'll pass it on to Katie now, and I'll see you all later.
Thank you so much, Vaishnavi. As Vaishnavi said, my name is Katie. I'm an educator at the Museum of Science, and my pronouns are she, hers. So I'm going to be doing a little bit of an introduction today because we're talking about quite a few things. We're talking about slime chemistry, which means we're going to be talking about chemicals. A lot of times when we hear about chemicals, we think of things that maybe are made by humans, things that are artificial like medicines or cleaning products we might have in our home. But chemicals also include things we find in nature, like water, for example. So a chemical is made up of matter. Any solid, liquid, or gas is going to be a chemical. But can a chemical be something that's not a solid, liquid, or a gas? This is going to be important to keep in mind as we go on with our slime chemistry experience. So in order to be safe, of course, chemists need to use PPE, personal protective equipment. So I'm going to put on some gloves here, just in case, because we are dealing with chemicals. I have some safety glasses. And I've made sure to properly label all of the chemicals I'm using today so that I know what's going on at all times. As Christina mentioned, we're starting with 3 chemicals today, polyvinyl alcohol solution. So what I'm using is school glue that has been watered down a little bit. And this works because school glue is a polymer just like polyvinyl alcohol. We're also using sodium tetraborate or borax. If you've seen that in the laundry section of any grocery store, it's pretty commonly used around the home. And as I mentioned, we're also using water. What observations can we make about these chemicals as we have them right now? So they're currently separate. See if I can hold it up close. Maybe my screen is mirrored, sorry if it is, but this is the PVA. So again, I'm using school glue in my at-home experiment, but can you kind of see through the bottle what's happening? What state is this chemical in? Is it a solid, a liquid, or a gas? Any guesses out there, Christina?
We're starting to get some thoughts coming into the chat. It looks like one person is saying a solid, another person is saying it isn't. The PVA is white and liquid. And looks like we have one more vote for solid.
Great. Okay. So let me see. It'll be hard to demonstrate here. Oh, I have a big bubble. So this is the PVA. And I can try and do a little bit. What do you see that's happening? Any guesses?
It looks like folks are saying we're still getting both up on the spectrum. Some people are still saying it looks like solid, and some people are still saying it looks like liquid.
So this is, like I said, it's school glue. I didn't put too much water in this bottle, so it is still pretty gloopy, but it is a liquid as it is right now. And I have a different chemical we're going to make observations about. This is the borax that I have. And can you see what's happening in here? This is going to be tricky as well. It's kind of hard to see on the screen, but this is actually a solid. These are tiny little solid particles, kind of like a salt, if you've seen salt around your home, or sugar. They're just little white crystals. And what I had to do to make the slime was dissolve that in water, our third chemical that I mentioned. So right now, what we have, or what we would have, are liquids. And I mentioned the word polymers earlier. Polymers, in this experiment at least, we're using linear polymers, and they're basically chains. I have a model of chains right here, and you'll notice if I drop the chains, they kind of fill out the bottom of the container that they're in. If I pick them up, they slide all over each other, but they don't come away in one piece. This is an example kind of our liquids that we're using. What we need to do is create a chemical reaction. So when we add that borax to water, the borax actually splits apart into sodium and borate ions. And those borate ions really want to stick to the linear polymers of the PVA or glue solution. So in my model, we're pretending these are the borate ions. I'm going to throw them into our container, mix it up just a little bit. And what happens when I pick it up? If I pick up the chains this time, we have a matrix polymer. So everything is stuck together, and it is slightly less movable than it would be, or than it was before. So this is a model of how we have made our slime. Let me make sure I got through everything. So while we are mixing things together, we're going to be looking for a chemical reaction. So I want you to be thinking about some examples of chemical reactions and what kind of chemical reaction that we're maybe looking for today. At the end, we're going to have slime, something that maybe isn't quite solid, liquid, or a gas. And my friend Vaishnavi is going to take over from here, show us a much more detailed model, and actually go through the process of making slime. See you later.
Thank you, Katie. That was a great introduction to how to make slime. So I will demonstrate how to make slime. But before we get started, wear your gloves if you're making slime with me now, because it's important. We're dealing with chemicals, and safety is always important. And I'm also going to put on these safety goggles just in case there is some splashing while I'm dealing with the chemicals. But before we get started, has any of you made slime before? And if you did, how was it? Was it sticky? Was it watery? Was it colorful? If you have made slime before and would like to share your experiences, please feel free to type it in the chat. And Christina can let me know when there are any responses.
Sure. Thank you, Vaishnavi. We'll give our viewers a moment to type in their thoughts in the chat. I will say that we have made lots of slime at the Museum of Science in the past, and I remember doing this with a lot of wee little ones as part of our early childhood space before. And it looks like a few thoughts are starting to come in. So one person says, they have made slime before, that it was a little bit sticky and colorful, but they think they remember using a conditioner to make the slime. Another person says that they've used ingredients like borax and glue, kind of like Katie was showing off at the beginning. And another person, I think, they don't know how to make it, but they said that it usually is a little bit watery, and they're excited to have another recipe.
Oh, yeah, all of them are right answers. So, slime can be made in several different ways using kitchen ingredients, and some recipes involve using borax and glue, like the one Katie mentioned, and the one I'm going to demonstrate now. And slime can be colorless or slime can be colorful. It depends on whether you add a coloring agent to that. Um, Here I have an already prepared ball of slime with me, and I just want to show you how it looks before we actually prepare slime. So as you all can see, it's just a ball of sticky substance, and I can just take it in my hand and just stretch it like this all the way, and then bring it together and just squeeze it in my hand, and we have the ball of slime all over again. So I'm just going to place it back in this, and I will talk about making this particular slime today. And Katie has already talked about the different ingredients that we're going to use, the chemical ingredients that go into making slime. So we know that slime is sticky. That's a common observation that we got. And so why don't we start with one of the chemicals that is also sticky? So something like PVA, or polyvinyl alcohol, which is found in glue. And we know glue is sticky. So why don't we just start off with PVA solution? So what we are going to do is, I have a beaker here, and if you see, it has markers here about the ml that's labeled. So I'm going to take 20 ml of this into the beaker. So I'm just going to keep filling it up until it reaches the 20 ml mark, and it just did. So here I have 20 ml of polyvinyl alcohol in my beaker, and I'm going to keep this aside. Now, what I'm going to do is, I want to make sure our slime is colorful, because colorful slime is good to look at, I guess. So here I have some blue colored glitter. It's a washable glitter paint. So I'm just going to put roughly, let's say, 10 ml of glitter. You don't have to measure it or anything, just approximately put some amount of it in it. And I'm going to take a glass stirrer, and I'm just going to stir this together. So let me see, we've added glue or polyvinyl alcohol, which is the key ingredient of glue, and we've added some glitter, and I'm mixing these two things together. So what do you think? Do you think when I stop stirring in a few seconds, our slime will be ready? Or do you think we need to make some more effort to get the slime ready?
It looks like we have some viewers starting to write some comments, and the Matthew family seems skeptical that we're going to be having any glue at the end of this first step.
Okay. Yes, we're only going to we're not going to have slime yet. It's just going to be the PVA and glitter together. So if you can see me moving this around, you can still see that it's just a liquid, and it's very watery. It's just a liquid, like you can see it. It's nothing close to slime, not yet. So we have to do something to turn it into slime. What do you think we should do? We probably need to add a chemical, but we wouldn't want to do it by trial and error. And so let's try to approach it scientifically. And like Katie talked about polymers using molecular models, I'm going to talk about EVA, the same thing, but a little briefly, because Katie has already discussed it in detail before. So what you see here is a string of beads, and you can consider each bead as a monomer, and several of them put together forms the polymer. So we can consider the bead of strings as a representative model of PVA, which is a polymer of polyvinyl alcohol, or vinyl alcohol. So I'm just going to take several of these chains together, and I'm just going to tangle them together, because that's basically what we did now. We just took glue and we stirred it up together. So after like tangling them together, if I try to stretch it, you see it kind of falls apart. So this is definitely not slime, and our molecular models say the same thing. So what if we try to break these into tiny pieces? So let me take this, and maybe I can just cut it off into smaller pieces. And if I were to do that to all the 3 chains using a chemical or a representative model for chemical, which we call a bond breaker, we end up with tiny chains. And let me just tangle all of them together and try to take them apart. I mean, they fall apart. So the chemical that we add here should not break the polymer chains, just like Katie described. So we need something that connects them so that they stick together. So let me put these things apart. And Christina, feel free to let me know if there are any questions coming up.
We don't have a question. We have more of an idea of what you could try, but it might be leading into what you're about to do. It looks like Sharon was noting that the solution was way too watery, and she thought maybe adding something like borax could help.
Yes, yes, that's absolutely right. And we're getting there. So you look at this model that I have in my hand. This is like a molecular model for the borate ion. So what we're going to do is we can actually take a piece of the polymer, or we can take the polymer and I can just show you how borate binds. So I can just attach borate to the polymer here to show how borate can form bonds. You see, like borate can connect this. And if we have another polymer with the other 2 beads here, we can link it up to the other polymer chain. So I have already done that for you, and sorry about that. So here, if you look at it, we have some connector, chemical connectors or the borate ions, representative models for that. And now if I try to stretch it, this stretches. It doesn't fall apart. So after we used chemical connectors in our models, we see that we have something that looks like slime that can be representative of slime. Now that we know we need to add a chemical connector, how much of that do we need to add? So let's look at what happens if we add too much of the chemical connector. As you can see, there's too many gold colored structures, too many chemical connectors. And if I try to stretch, you see, like it doesn't really stretch much, it doesn't really stretch much because it's just too stiff. So too many connectors will just make it become too stiff and too hard, and we will not really have a slime that is stretchy. So with the help of molecular models, what we just saw was that we need a chemical connector, but we need to add it carefully in measured quantities so that too much of it will not make it too hard, or too less of it will not leave it too watery. We just need to find the right amount. So let's go back to making slime. So here we have the polyvinyl alcohol and glitter solution that we made. And let's take borax. So borax is the chemical connector that we are going to use. And as Katie mentioned, this solution has borate ions that will form cross links between the different PVA chains. So it's ideal to add 5 ml, approximately 5 ml of this solution, borax, to the PVA and glitter in the beaker. So I'm going to add it slowly, and I'm going to stir it while I'm adding this so that we know what's happening. So I'm just adding a few drops, and I'm stirring it, and I'll just stop adding for a moment and then just stir it here. Maybe just show it to you. So I've added a few drops of borax, and I'm stirring, and let me just take out the stirrer to show you what happens. Do you see what this is? You can feel free to type in your responses. What do you think it is that is sticking to the glass stirrer? What is it? The substance that's just sticking hard to it.
It looks like folks are saying that it looks very sticky. Maybe we're finally starting to make some slime. And a lot more people saying it looks like the slime is coming together here. So one other person said that it looks to them like Jello.
Yes, that's all right. Yes, that is definitely how slime looks like. And yes, this is the slime that's forming. But you also notice that not everything has turned into slime. We still have a lot of watery substance here. So why don't I go ahead and add a little more of borax to this, a few more drops, and Why don't I just stir it for some more time, a little more, to see if some more of that watery substance can turn into slime. So, what do you think? If you have any thoughts about it, please feel free to write it in. What do you think will happen if I added too much of borax? I'm like measuring it very carefully, but what would be your prediction if I very rashly added a lot of borax?
And it looks like folks are saying that it's starting to look like slime, but they're worried that if you added too much borax, it might look like clay or it could be too hard and stiff. Somebody has had that experience happen to them before in the past. Someone else said it would be really hard. And another person said that then it wouldn't really be like slime anymore.
Yes, that's all right. That's all correct. I myself had that experience before, and where I added too much borax, and it wasn't like slime at all. It was just too stiff. Do you see we have like more slime now that we added more borax? Um, I guess I will just add a few more drops of it and stir it for like one last time just to get any remaining liquid off. So I'm just going to add a little more and just stir it. I think we're almost there. Um, so I think we almost have our slime ready finally. So what I'm going to do now is I'm just going to take all of this slime that's sticking to the glass rod and put it back in the beaker. And I'm just going to get this in my hand and probably just roll it in my hand a little. Just there's a little watery substance, but that is okay. I guess we can add some more borax and then like turn that into slime too, or we can just ignore that and just move on with what we have, keeping in mind the time constraints. So as you see, I have in my hand a ball of slime similar to the one I showed in the very beginning. And let's see if this stretches. So we have it here, and then can just, well, it seems to stretch pretty well. And how long do you think it will stretch? Forever? Do you have any thoughts?
It looks like a few folks are saying that it looks really watery and slimy, but maybe you could keep stretching it for about a minute if you keep pulling very slowly. But yes, that looks like people are just commenting on how stretchy it looks.
Yeah, yep, it is pretty stretchy, and that's because we haven't added too much borax. We've measured it and carefully added the right amount, so it's pretty stretchy. And you're all right that we can keep stretching it, but unfortunately we cannot stretch it forever because and if you try to stretch it like pretty fast, it breaks immediately. Like this, it just breaks off. But like I was stretching, like if I kept stretching it very slowly and maybe for a minute, it'll go pretty long. But at some point it will break, it will start to break. We cannot stretch slime forever, but we can stretch it for some time. um, so this is how we make slime. And now that we have made slime, what are we going to do with it? How do we keep it, or like how do we use it? So first things first, we see that there's some liquid left in this. If you want to spend some more time, you could add some borax to it and turn this into slime too, so that you have a bigger ball of slime. Or what you can do is you can just leave it aside and leave it open. It will dry out if you leave it overnight, and you can clean the beaker up the next morning. And coming to slime, I would suggest that you store the slime carefully. So take a clean container and place your ball of slime in it carefully. And remember to close it with a lid so that your slime doesn't dry out. I think I can show you an example of what happens if your slime dries out. So it basically becomes pretty hard, and you see like it just becomes like plastic, and it's just like too hard here. So it loses the water content and it just becomes too dry and too hard. So I would suggest not to leave slime in open close it, pack it, and it should be fine. Slime doesn't usually go bad for several weeks and even months, but if you ever notice any bacteria or mold, or if you see that it's starting to smell real bad, or there's some sort of a liquid coming out, just feel free to just throw it away. And you can throw it away with household trash. You don't have to worry about anything there. Um, and you can also try out some other interesting things with slime. Slime is usually used as a stress reliever, like a stress ball. You just squeeze it in your hands and you feel better because you're relieving your stress. But you can try taking a little bit of slime and adding it to water. Add a little bit of water to a small portion of slime and see what happens. Or you can take a little bit of slime and try to stick something together and see if that works as a glue or not. So there are some interesting things you can try out with slime. And if you have any questions, please feel free to type in the chat, and I'll be happy to take them.
Excellent. Thank you so much. And we have a couple of thoughts, I think particularly related to the materials today. So one question is, if you don't have access to PVA solution, would it be possible to use an alternative material like school glue?
Yep, school glue works perfectly fine. Yes, that can be used.
Perfect. And then for some of the other materials, Vaishnavi, for example, the borax, do you know where someone would buy that?
I think it can be found in, I think it's not hard to find it in a grocery store, like in the cleaning sections. I think it can be found there. Or if finding a dilute solution of borax is hard, you can always make slime with kitchen materials, where you can use baking soda, for example, or just like milk and baking soda or things like that. But I think you can get borax pretty easily in a grocery store.
I think you might be right. I'm pretty sure I've bought borax like in the laundry section of this grocery store in the past. And I'm just popping back in now because I see that we are just about out of time. So I wanted to see if we could thank Katie and Vaishnavi one more time before they say goodbye to the audience. Thank you, everyone.
I hope you've enjoyed it. Thank you.
And I think people did enjoy the program because we had a few people saying that this looks like fun and they would like to maybe try it later today or later this week. And I will remind everyone that if you want to make the slime that our educators talked about today, these were the 3 materials that we use. And thank you so much for sharing your observations and your questions with us today. What I will note is that if you'd like to see more Chemistry Week programming, we're going to continue this throughout the week. And you can find out more about Chemistry Week programming at the Museum of Science by visiting our website at www.mos.org/chemistryweek. Also, if you do any of our chemistry experiments, we'd love to see the results of them. And if you have a picture or a video on social media, you can use the hashtag MOS at home so that we can follow along. If you want to see other kinds of science programming, especially next week when we move to other topics and not just chemistry, you can look at all of our offerings on our website at mos.org/mos at home. And if you enjoyed the program today and would like to make a donation to the museum, you can find out about how you can support us to keep doing this kind of programming at engage.mos.org/welcome. But thank you for joining the program today. We hope you enjoyed it, and we'll catch you at the next one.